subject. We're going to be talking about writing and solving inequality word problems. And this shouldn't come as a total surprise because we've been doing this kind of repeatedly first with equations, then with linear equations, and now with inequalities, where we learn how to write and solve them, and then write them using word problems, and in some cases solving them as well. So some of the same things that we've seen before will apply here, and I think it'll be quite a lot of fun. So let's get going. So as we write these, we're going to be looking for keywords that will indicate whether or not we'll use addition, subtraction, multiply, or divide in our inequalities. We'll look for keywords for the inequality symbols and write and solve the inequality. So let's talk about what we mean. Well, here's some of the words that you might see. Like if you see the phrase is less than or is fewer than, you're probably going to want to have the less than symbol in your inequality. If you have the phrase is greater than, is more than, that would probably mean the greater than symbol. Less than or equal to, you could look for that symbol. Is at most. Oh, is no more than. A little different way of wording that, but both of those mean less than or equal to. And then on the other hand, if you want to look at greater than or equal to, phrases that mean that are is greater than or equal to, or is at least, or is no less than. So you're going to see those as you go through some of these assignments. So let's get started. Karen will spend less than $35 on gifts. So far, she has spent $17. What are the possible additional amounts she will spend? Use C for the additional amount in dollars Karen will spend, and then write your answer as an inequality solved for C. So let's start out with C. This is the amount of money that she would like to spend on gifts. So far, she has spent $17. So the amount that she will yet spend plus 17 is getting us started. Now it says that she will spend less than 35 total. So that just means that we're going to put a less than sign in there and the number 35. So there's our inequality, and if we solve it for C by subtracting 17 from both sides, like that, we're going to end up with the amounts of money that she could still spend. So 35 minus 17, 15 minus 7 would be 8, and 35 minus, well, when we do that, we actually have a 2 up there. 2 minus 1 would be 1. So she can still spend something less than $18 and still stay within her budget of $35. So she could spend 18 or 17, 16, 15, any amount less than 18, and she would be just fine. Okay, let's try another one. Deborah runs each lap in 5 minutes. She will run less than 40 minutes today. What are the possible number of laps she will run today? And use L for the number of laps she will run today. So she can run each lap in 5 minutes, so we need to take that into account. So 5 minutes for each lap, so 5L. And if we knew how many laps she ran, that would tell us how many minutes that she ran. Now we know that she's going to run less than 40 minutes. So basically what we're saying is, if she can run laps at this rate, how many laps can she squeeze in the 40 minutes that she has to exercise today? So there's our inequality. We divide by 5. And the number of laps that she could possibly fit in would be anything less than 8. And a lot of that's going to just depend on how good she's feeling today, whether or not it starts raining, or is it too hot out there, or is she just too tired to run that many. Anyhow, she can run anything less than 8 and still have time to do the other things that she needs to do. Okay, Gina buys candy that costs $8 a pound. she will spend less than $72 on candy. What are the possible numbers of pounds she will buy? Okay, so we know that the candy costs $8 a pound. This is one of those candy stores where whatever kind of candy you get, each flavor costs the same amount. So it's just a matter of how much you get and what kind you get. So it's $8 per pound, so I'm going to put P on there. And then we know, so we're going to multiply those two together. And we know that she's going to spend less than $72 total on the candy. So maybe she has a budget of 72, but she doesn't want to spend all of it. So she'll spend something less than 72. So then if we divide both sides by 8, then we will get our solution of P is less than 9. So as long as she buys less than 9 pounds, and this is pounds, by the way, if she buys less than 9 pounds of candy, then she will be able to stay within budget and stay under $72. I'm kind of liking these inequalities. They're kind of fun and they're very useful. Okay, Elsa runs each lap in 5 minutes. She will run less than 9 laps today. What are the possible numbers of minutes she will run today? So we know that for each lap she runs, she can run it in about 5 minutes, right? So 5 minutes per lap. But she's going to run less than 9 laps. So the question is how much time could she possibly run as an inequality? So if we multiply both sides of our inequality by 5, we end up with, actually that's supposed to be t, right? So then t is going to be less than 45 minutes. So as long as she runs less than 9 laps, the time amount that she's going to run is less than 45 minutes. And then if she's kind of short on time, she'll be able to get done in time to do whatever else she needs to do. So that one is worded a little more differently, so kind of watch the wording as you do these. Okay, Jim, and this is kind of like what you're going to see on Alex too. Jim is buying nuts. The nuts cost $3 per kilogram. He will spend at least $33 on nuts. I should say nuts, not huts, huh? On nuts. Let's look at the possible number of kilograms of nuts Jim will buy. Fill in the blanks to write an inequality that can be used to find x. The number of kilograms of nuts Jim will buy. Okay, so the nuts cost $3 per kilogram. So that sounds like we're multiplying, so 3x. So for our inequality, we're going to bring it down to 3x. And he will spend at least, so at least means greater than or equal to. So that symbol will go next, greater than or equal to. And then 33 will go right here, so $33. So that's how you'd use those symbols to write that inequality. And you can just kind of drag them in there, and whatever tools Alex gives you to create that inequality. Now in this case, we don't have to solve it. Oh yeah, we do, look at that. We got to make sure we page down and watch all of our solutions. So in this case, we've got to divide by 3. And we get x is greater than or equal to 11. So he can get greater than or equal to 11 kilograms of nuts. So if we come down here on our little graph, we get to decide where 11 is. So we'll just say 11 is right about here. And we want to show greater than or equal to that number. So we would put a solid dot at 11 and an arrow pointing to the right. So that would be our graphed solution to this particular inequality. All right, so today we're going to be doing number 34, inequality word problems, day 1 on Alex. So good luck, have fun.